Everyone, in this video we're going to go over section 7.1 on functions, undefined and general sets. So now let's go once again over the definition of a function. So a function f is defined from the set x to set y, and we can write that as f going from x towards y, and it's a relationship from x to y that is going to satisfy that every element on x is related to some element on y, and no element of x is related more than once to an element of y. That's the conditions for being a function. Now here the key terminology is x is going to be the domain of f, y is going to be the codomain of f. Now for any x that is in the domain, the unique element y that belongs on the codomain with f of x equals y is called the image of x, or the output. We write that as f goes from x to y, or x is going to y through f. Now, in the codomain, we have a specific set that is the set of all the images of elements of x. So the range of f is defined as all the y's that belongs to the codomain, so that y is the image of some x. Notice once again, range is going to be a subset of the codomain. They might not be equal. Now we can also define the inverse image. So given a y that belongs to the codomain, the inverse image is going to be the x, so that f of x is equals y. Each x in this way is called the preimage of y. Now, it's very important to know that the inverse image of y might be empty, where we don't have a preimage that says a single number, or it can be even a larger set. Now let's look at one of the representations of functions with arrow diagrams. So first, we're going to go with the notion that each element of x must be exactly one arrow to y. So for example, this here will not be a function because we have element in x that are not related to elements on y. So b has no relationship with anything on y, so it's going to make it not a function. Now, we can also have that one element in x is going to have multiple image on y. Like this situation here, c goes to 2, c goes to 3. This is not a function because of that. This cannot happen in a function. The image of c needs to be a single element of y. Now, c is an example of a function. We have that a, b, and c are related to different elements on y. Notice that we don't cover 4 on y, but we don't need to. We just need to cover all elements on the domain. Now, let's take a look at another example with a different way to write the relationship. We're sending f that comes from the set ABC to the set of 1, 2, 3, 4, so that we send A to 2, B to 4, and C to 2. Notice that this can be represented on the arrows as A is being sent to 2, B is being sent to 4, and C is being sent to 2. Is this a function? Yeah, it is a function. We cover all the elements in x, and they're going to one element on y. We have empty elements on y, but that's fine. The domain here is going to be A, B, C. The codomain is going to be 1, 2, 3, 4. The range, though, is only going to be 2 and 4, since those are the images that we actually get from our function. When we're doing f of a equals 2, f of b equals 4, and f of c equals 2. The inverse image is going to be a and c, because those are the elements in x for 2, the image of 2. It gives me a and c. The inverse image of 1 is going to be empty because we don't have anything through f going to 1. As pairs, we can also represent this function as the pairs a2, b4, c2. Notice that in this case, the range is not equal to the codomain. It's a subset. Now let's see some examples of functions. One of the important functions that we're going to be using later is going to be the ceiling. The ceiling is defined with this symbol. Notice that it has like a little ceiling on the top of the x, and is given as the smallest integer that is bigger than x. So pretty much this a lot of the time is going to round up things. So if we have 3.4, the ceiling of 3.4 is going to be 4. The ceiling of minus 2.5 is going to be minus 2. The ceiling of 5 is going to be 5, since it is an integer. Notice here that this minus 2.5, you might be thinking, who's the biggest? And so because it's negative, you might think that minus 3 was going to be the rounding here. But you got to remember that we're rounding up. So we're going for the smallest integer that is bigger than this. Minus 2 is a bigger number than minus 2.5 in terms of negatives. Now, similarly, we can have the floor. The floor, it kind of does the opposite, and it takes the greatest integer that is less than x. So this is going to round down. So, for example, if we have 3.7, the floor of that is going to be 3. If we have minus 3.8, now because we're rounding down, so we're looking for the greatest integer down, so we're going to have minus 4 in here. This is the greatest integer that is less than the element that we have, and that greatest integer less than minus 3.4, minus 3.8, sorry, is going to be minus 4. Once again, when we're in an integer, that's just going to be the same number. So floor of 5 is just going to be 5. One common mistake here will be mentioning what I did before in terms of if you have the floor of minus 2.5 is minus 2, not minus 3. And if you had the floor of minus 2.5, that's going to be minus 3, not minus 2. So you got to be very careful not to confuse these two functions. Now, the identity function is one of those functions that also can be used for any domain. So here we have the identity of the domain X that is going to be sending the domain set X to X itself of the range, and is sending any element and the same element. So the identity of A sends just to the same A. Now in this case, every element maps to itself, so the range is going to be equals to the codomain, and it's going to be equals to X. One example of this is like, let's take G from C to C. So here we're going. And notice that we're not taking the identity, but we're taking G of n equals to n. So in here, although we're sending from C to C, there's no reason why it has to be the identity. This 2n is going to send any number to twice that number. So although the domain and codomain is still going to be the integers, the range of integers that send is all the even numbers, so 0 to 4, and also the negatives, which is a subset of the integer, but it's not all the integers. Another example of function will be the function h of x equals x squared. Here, any number is sent to the square of that number. And so for that, the range is just going to be 0 to infinity. We're not going to have negative numbers, and that's a subset of the real numbers. Now, just to make an example of inverse images here, for example, if we get 4 in the other side, we're going to get back that the image inverse of 4 is going to be 2 minus 2. So this particular function is not one-to-one. It's not sending all the elements to just a single element, and that's going to be the only one relationship that they have. This might be sending multiple elements to the same place. Now let's talk about functions of subsets. So for example, here we're going to have f from x to y, and let's take a subset of x, and let's take a subset of y. We talk about the image of A as the y that belongs to the codomain, so that y is equals f of x for some x that belongs to A. So we're pretty much looking strictly for the image of A. In the same way, we can talk about the inverse image of C. So if we take, if we consider all the x in domain such that f of x belongs to C, then we can call that the inverse image of C. Let's talk about one example for these definitions. So consider the function that sends 1, 2, 3, 4 to the numbers a, b, c, d, e, with the relationship f of 1 equals b, f of 2 equals a, f of 3 equals d, and f of 4 equals b. So let's consider some sets. Let's say A is going to be 1, 4, C is going to be AB, and D is going to be CE. So A is a subset of the domain, and C and D are a subset of the codomain. Now, the image of A is just going to be B. Why? Because notice that f of 1 is B, but f of 4 is also B. So the image of all this set is just a singleton here, a single element. Now, if I consider the image of the whole set, the domain of 1, 2, 3, 4, then of course that's going to be sent into A, B, and D. So this is providing me with the range. Now, if I think about, well, what is the inverse of, let's say, C? And so with C, we want to look at the x so that they're related with A and B. So A and B, we have 1, 2, and then you see 4 also here. Since B is related to 1 and 4, 2 is related to A, we're going to have that ABD is, that 1 to 4 is going to be the image inverse of C. Now, for D, which is this CE, notice that because we don't have any elements that go to CE according to this definition, then the inverse image of D is going to be the empty set. It maps nothing into D pretty much. All right, so in summary, we discuss function and how every element of the domain maps to one element of the disaggregatedly one element of the codomain. We define domain, codomain, and range. We found also the definitions for image and inverse image. And we discuss about how to visually represent functions through arrow diagrams. We have some special functions in floor and ceilings that is worth for you to be remembering. And in terms of common mistakes to avoid, you gotta be careful not to confuse range with codomain. You don't want to be thinking that a function must be one-to-one necessarily. You probably going to have multiple inputs that can map into the same output. The floor and ceiling, they function different with negative numbers. So make sure that you're always checking on that. Always go further from 0 for floor, closer for ceiling. The inverse image is not always a single element. It can be empty, a singleton, or contain multiple elements. All right, so next we're gonna go into the definition for one-to-one and onto functions.